Hello everyone, this is the first lesson recording for IM2, March 4th, 2021. We started off with doing quiz number 3. So if you missed it for whatever the reason, please contact me as soon as possible so that you can make it up. I am going to start off by showing students' work on homework number 13. Okay, this problem was number 6, question number 6 on homework number 13, where he's supposed to solve using quadratic formula x squared minus 2x minus 99 is equal to 0. I like many things that this student is doing, but he is also it shows a very typical common mistake, and that is part of the reason that I am showing you. So first thing, he correctly numbers the problem, but what would have been better is if he started off by writing the equation as well. So right at the top, I would actually start by writing x squared minus 2x minus 99 is equal to 0. Okay, and for now, it would have been good if he identified all the numbers. A is equal to 1. B is the number in front of the x, so B is negative 2, and C is negative 99. But the student correctly substitutes all the values in, okay? He did not make any mistake. That is actually a common mistake when students are substituting them in, especially when they do not write A is equal to B is equal to C is equal to, they sometimes substitute the wrong value. Okay, so he put negative of negative 2 plus or minus square root of negative 2 squared minus 4 times 1 times negative 99 all over 1 times 2. Okay, the first thing I would say is I like the way he's using parentheses here, but he really should have used another parenthesis here, because negative 2 squared as he's written it should be negative 4, not positive 4. Because negative 2 all squared is very different from negative 2 squared without the parentheses, right? So he should have done that. But from the next line, I see a problem. What did he do wrong? Okay, so negative 2 squared, though he did not write it correctly, he did interpret it correctly and wrote down 4. Here, negative 4 times 1 times negative 99. This negative times negative should be positive. It's not 396, it's positive 396. So this should have been 4 plus 396. This is what I mean by when you're using quadratic formula, it is very easy to get the plus and minus signs lost, okay? And another typical common problem I see is a lot of students lose either this negative sign or this negative sign. So make sure you're using parentheses and doing it correctly, and make sure you're using not losing any of the negative signs. Okay, so then in this case, 4 plus 396 should be 400. Okay, so this student, let's just pretend that this was correct. Okay, 4 minus 396. This is yet another problem. Okay, 4 minus 396 should have really given him negative 392. But he just decided to ignore the negative sign and go with the positive. And then he said it was going to be plus or minus square root of 392 and 2 minus square root of 392. Again, another problem that this student did was, even if this was correct, he should have simplified the radical. I know that 392 is at least divisible by 2. Okay, something else. Okay, so if I was to write, let's just assume that this answer is correct. I also want to show you something. X is equal to 2 plus square root of 392 all over 2. Let's just deal with that problem. That's going to be 2 plus, okay, so that's divisible by 4. That's going to be square root of 4 times square root of, that's going to be 98. Yeah, all over 2. Okay, when I do that, divided by 4, then I know that this is going to be 2 plus 2, and when I look at square root of 98, I see another perfect square factor. That's square root of 49 and 2. Okay, by dividing with the number that you know is perfect square, as the numbers get smaller, you're going to be able to see the factors a little bit more clearly. So then this becomes 2 plus, okay, so 2 times square root of 49 is 7, so 14 root 2 over 2. Now when you have fraction over fraction, you can separate this as 2 over 2 plus 14 root 2 over 2. And the first part simplifies to 1 plus 14 divided by 2 is 7 root 2. So this would simplify to be 1 plus 7 root 2. That assumes that this is correct, and we've said that this is incorrect at many levels. But if this was correct, the final answer should be 1 plus 7 root 2, which is much simpler than what he has. Okay, something else. All right, something else, and this is a very good segue to what we're going to be talking about. If this square root of negative 392 was true, if you ever get this square root of a negative number, and you are going to get that sometimes because not all quadratic equations are going to yield a positive square root here when you use a quadratic formula, then this should ring a bell that there is no real solution. And I have heard some students ask me, what does it mean by no real solution? That means no real number solution. And we are going to be talking about exactly that today. What do we mean by real number? Aren't all numbers a real number? I mean, are there not real numbers? And that's where the complex number and imaginary number comes in. So we're going to get right into that. Goal for the day is that we're going to be introducing you to complex numbers and imaginary number. But before we do that, we are going to be looking at different types of numbers. So we are going to start by watching a 6-minute video. I am not going to show it right now, but I am going to put it in the Canvas link for you to be able to watch it. Please do so. So now let's talk about number classifications. So different types of numbers were created out of need. We started off with just counting numbers, or what we call natural numbers. Which are counting numbers, and numbers representing countable quantities. But then we needed the number 0. Okay, so it's the natural number plus 0 is the whole numbers, what we call whole numbers in mathematical world. But such as, so now we have expanded to 0, 1, 2, and many other numbers, counting numbers only. But then we figured out that, oh, we could really be benefiting from having positive and negative numbers. Okay, so we wanted to extend that beyond the positive numbers and 0. We want to introduce the idea of negative numbers like negative 42, negative 2, and negative 1. And then we expanded it to rational numbers, as we discovered that if it would be really helpful for farmers and many other reasons if we could introduce fractions to the number system. Okay, so when you hear the word rational numbers, here the first 5 letters should be saying ratio. When you hear the word ratio, it should be making you think about fractions. So rational numbers are numbers that can be represented as fractions. So ratio of integers are what we call rational numbers, like 10 over 5 and negative 9 over 7. It can be both positive or negative. And then we came to irrational numbers, and irrational numbers are numbers that are not rational, such as square root of 2 or square root of 6 or pi, and etc. Okay, so these are numbers that cannot be represented as a fraction, and when you represent it as a decimal, it's a number that goes on forever. Then the question comes in, where do decimal numbers fit in? Well, the natural numbers include 3.0 or 5.00000. So decimal numbers are included in natural numbers, and whole numbers such as 0.0, and integers. Any integers can be represented as decimals and rational numbers. Okay, so say a quarter can be represented as 0.25 or 1.3333. This means it's repeating, right? That is really same as 4 over 3. And any repeating decimal can be represented as a fraction. Okay, so when you have a pattern of numbers that are being repeated over and over again, it can always be represented as a fraction. So terminating or repeating decimals are included as rational numbers. Then there are numbers like 1.73025. I mean, there are decimal numbers that does not have any repeating pattern. It's just some random numbers combined, and that is square root of 3. So square root of 3, if you try to represent it as a decimal, it is a number that goes on forever. So when we sort of cut it off as 1.73 for the sake of simplicity for our calculations, we're really approximating it. Okay, while a square root of 3 is the exact value, 1.73 is approximate value. Even 1.73025080075, even though it has many digits, this is still an approximate value of it, because there are many more digits that tells you that it's not exactly that. Okay, so it's a decimal number that goes on forever, that cannot be represented as a fraction. So therefore it's a non-terminating and non-repeating decimal. So with that, here is a Venn diagram. So natural numbers are numbers like 1, 2, and 4, and 42, and so on. But if I introduce 0 to the natural numbers, now we're in the realm of whole numbers. So whole numbers include 0 and the natural numbers. But then integers include positive and negative numbers. So it's when you include the negative numbers plus whole numbers and natural numbers, we're now talking about integers. And then rational numbers are when we include any numbers in between the integers. So in the fraction form, or in decimal form, or terminating decimal, or repeating decimal are all rational numbers because they can be represented as a fraction. Then there is another set of numbers called irrational numbers that cannot be represented as fraction, such as square root of 2, square root of 7, and pi. And all these numbers together we say are real numbers. Okay, so these are all real numbers. So rational numbers, irrational numbers, integers, whole numbers, and natural, they're all real numbers. Complex numbers are something that is beyond real numbers, and we will talk about that in a little while. But before we do that, you are going to be working on decimals, card number 1 to 5. So please pause the video and do them now.